Welcome back. In this video, we're going to pull up and work through an example of a hypothesis test for a population proportion. So in February 2008, the Gallup organization surveyed 1,034 adults between 30 and 64 years of age and found that 548 of them were worried that they will outlive their money after they retire. Does the sample evidence suggest that a majority of 30 to 64-year-olds in the United States are worried they will outlive their money? Use the alpha equals 0.05 level of significance. Now notice that we're trying to determine if a majority of 30 to 64-year-olds are worried they'll outlive their money. That means we want to know if the true proportion is greater than 0.5. And so that implies that our hypotheses are going to be HO, P equals 0.5 versus H1, P is greater than 0.5. But now, before we can run our test, we need to confirm that our test assumptions have been satisfied. First, we're told that the Gallup organization surveyed 1,034 adults between 30 and 64 years of age. So let's assume that the Gallup organization performed a random sample from this population, and so that satisfies our first condition. Second, we need to check that n times p sub 0 times 1 minus p sub 0 is greater than or equal to 10. So we multiply 1,034 times 0.5 times 1 minus 0.5, and that turns out to be 258.5, and that is definitely greater than 10. And so our second condition is satisfied. Next, we need to check that our sampled values are independent of each other. Now remember, we said that we can check this by checking that our sample size of 1,034 is no more than 5% of the population size. Well, certainly 1,034 adults from 30 to 64 years old is far less than 5% of the total number in that population. So we can consider that this assumption is satisfied. And so all three of our assumptions are satisfied, and now we can proceed with the test. So in step 2, we identify our significance level. Remember, we were told that our significance level for this test would be 0.05. And now in step 3, we calculate our test statistic. Now first, we need to calculate p hat. That's the sample proportion of 30 to 64-year-olds who are worried they will outlive their money. That's going to be p hat equals 548 divided by 1,034, which equals 0.53. And then we plug this value into the test statistic. Now you might want to try working through this by hand just to get comfortable with the calculation, but it's basically just something we can let the software calculate for us. And so the test statistic, z sub 0, turns out to be 1.93. And in fact, when we run this through StatCrunch, it also gives us the value for the test statistic as about 1.93. And the corresponding p-value is 0.0269. So we write down the p-value of 0.0269 and then sketch in the p-value region on the z-distribution. Remember that the p-value is represented by the area under the curve to the right of the value of the test statistic 1.93, because remember this is a right-tailed test. And next is step 5. We compare the p-value to alpha. Since our p-value of 0.0269 is less than alpha of 0.05, we're going to reject the null hypothesis and conclude the alternative. And so in step 6 we say, at the alpha equals 0.05 significance level, we do have sufficient evidence to conclude that a majority of adults 30 to 64 years of age are worried that they will outlive their money after they retire.